Hello, dear YouTubers. This is my first video on Hyperledger Fabric tutorial series. The reason why I put this tutorial is because I wanted to help people who wanted to get into the blockchain space, particularly young developers and particularly those who are in IT industries, doing some testing job, doing some programming as a software engineer, and they wanted to move into a different and at the same time an interesting technology stream. So in today's world there are three buzzwords. One is blockchain, and is AI, and another one is IoT. Of course there is AR and VR, which is not very that popular yet, but these are the three main buzzwords that is running around in the industry. So today we are going to discuss about the blockchain, particularly Hyperledger Fabric is one of the very popular framework that exists today in the blockchain space. And if you want to get a job in a company, then the framework that you have to choose is Hyperledger Fabric, none other than Hyperledger Fabric, nothing else. Okay. So for you to understand Hyperledger Fabric, it is very difficult to find online resources. It's very difficult to find appropriate courses that explains you how to do it, how to right from downloading, installing, explaining the concept. There is no much of resources that is available in the online. That is the reason why I picked up Hyperledger Fabric and I wanted to make a video about it. And second reason is there are a lot of questions. Okay, there are a lot of questions everybody has. Most of the developers that do not understand the concepts around Hyperledger Fabric. It is very complicated in certain way, because the way they've created the documentation and the actual need in the industry, there is not really a good balance out there. When I started Hyperledger Fabric, I found very difficult to learn this. Okay, because there was no good resources at all. Nowadays there are a few resources. I've seen a lot of YouTube channels that helps to create a fabric, and I also found many articles that is running around. So I thought I'll also contribute a little bit on that. So that is why I started this tutorial series. So before we get into the tutorial series, I want to set some expectation, like who it is, who will be the audience of this particular tutorial series. Okay, there are some prerequisites, like okay, one, at least you should know something about the development. You should have some knowledge about development, how to build an application, what is a database, how to connect a database, REST applications, UI and stuff like that. Some fundamental logic about development is necessary for you to step into blockchain. Okay, so that is the prerequisite. So it doesn't matter which technology, whether you are from Java, .NET, Node.js, it doesn't really matter. You should know development. Okay, you should be a developer first place. And if you know Node.js, it is much better, because we are going to build this application from the Node.js perspective. Okay, though Hyperledger supports few other languages like Java and Golang, but in this tutorial series, this is primarily a Node.js based tutorial is what I've been thought of going to do. So if you know Node.js, hooray, it's going to be much easier for you. Otherwise also it's okay, still you will be able to grasp the concepts and you can apply in whatever language you know. Okay, so this particular video, which is the first video of a series of videos, so this particular video is going to set a base. I'm going to tell you what is blockchain at first place, and history of a blockchain, and a little bit demo here and there. Because right away I don't want to jump into Hyperledger Fabric, how to do a chain code and stuff like that. I want to give you a little bit introduction about what is Hyperledger Fabric, and then I thought it will be good if you go into detail about Hyperledger Fabric. So if you know what is a blockchain already, okay, you have worked in platforms like Ethereum, or what is a smart contract and stuff like that, then I say okay, you can skip this video completely. You can start from the next video, but this video is to set the base, okay, to to give an introduction about what is this world is all about. Okay, so let's see what we are going to see, or what we are going to discuss about in this video. Okay, so what we will learn in this course. So this is a little bit introduction about blockchain, because straight away we cannot jump into what is Hyperledger Fabric. So you should understand why blockchain came at first place, right? So we're going to talk a little bit about history, definition of blockchain, why blockchain came into existence, and what are the types in blockchain, and where does Hyperledger fall into those types, and a little bit introduction about Hyperledger, right? So that is what we are going to discuss today. I'm going to show you a small demo how actually blockchain works in the background. So let's keep it simple, right? Okay, let's jump into our session. We start with what is a blockchain. Yeah, so we need to have the definition of blockchain. So to define a blockchain, there could be many actual definitions, Wikipedia definitions, but this is the definition that I like the most. Maybe it's my definition. Okay, so a blockchain is a data store that you can trust. Okay, so it's a loaded statement, so you should understand like what do you mean by a data store and what do you mean by trust in this place. Okay, so does that means any data store that exists today is not trustable? Yeah, so let me tell you how this works. Let me tell you where it all started. Okay, everything has a genesis, right? So which means everything has a starting point. So let's come from there. Okay, let's understand the starting point. Okay, all it started here. The picture here, can you see, right? So you have a lot of information. Everybody has a lot of information that they wanted to keep it, store it, okay, in a form of files, maybe your certificates, your bills, your let's say if you're running a business, your data of the company, your employee list, or his attendance details, or the contracts that you have with your clients, contract with your suppliers, documents related to your information. There are so many information, personal data, like your photographs, um, your music files, video files, so on and so on. A lot of files used to be there. In olden days they used to keep it as a in a raw format, like an actual file, actual paper. And we used to store photos were physical, right? We used to had albums where with that big book, whenever comes to your home, open and show it. But there was one problem with that. Okay, problem is that it occupies a lot of space at your home. Okay, number one. Number two, when the data is more, it's so difficult for you to go and search for an information. Okay, and number three, the longevity of the data. Okay, because the data in a physical form does not last longer. Okay, it takes a lot of uh, you know it gets rusted, it gets damaged, it gets there are many accidents that can happen, and if there are possibility that you lose your data forever. It has happened many times, many places. So always we wanted data to be protected, and that is when the digitization era started. Okay, the computers made a lot of difference when handling the data. Okay, so people started realizing the importance of storing information in a computer. But how can we store some information in a computer? Computer is a device, it's a digital device, but you have to store this data in a certain format, right? You have to store it in a place, like say you put an organization, you create one big folder in your C drive or D drive. You name appropriate folders for each kind of files. Let's say there is a certificates folder, you keep all your certificates in it. Let's say important documents, and you put the important documents in it, and you create another folder called pictures, another folder called videos, and stuff like that. Okay, that was the initial way of handling data. Okay, it is just a replica of what we used to do in a real world. We just try to recreate that in a digital world. That's what happened. But then it is again a problem. Okay, because even in digital world, searching for something is always difficult. Okay, you have, say for example, you have a folder and you have some 10,000 photos in it, and you want to search a photo which was taken in a place called let's say Goa. Okay, so how are you going to do that? You will have to scroll through all the images. Maybe you may have thumbnails through which, anyway, end of the day, if you're like searching among 10,000 image files, then it's going to be very difficult, right? Same with any other types of data. So it is storing these files as a flat files and in a folder. It's not a very efficient way of handling the data. So that is when the concept of database become very popular. Yeah. So instead of keeping information in a file, I mean your important data, instead of keeping it in files, you will keep it in a database. Okay. The advantage it gives is the database keeps your data secure. You can give roles and responsibilities, users, access levels. You can back up this data. You can migrate from one system to another system. You can have another backup in a cloud or somewhere. Okay. So there are a lot of possibilities that open with the database, and you can easily get a data, like any data you want, in a split second. That was the advantage that database gives us. And even today, you can't imagine an application without a database. Okay, database is that important when there is a data. Okay, so that is one thing you need to remember. But then the problem is this. Okay, so it's all good. Okay, now database is there. We can store large amount of data in the database, and you can query this database and get your data, whatever data you want, in a split second. It all sounds good. You can create a really secure user access to it and make sure your data is also safe. But is it really safe? That is the question. Okay, the problem arises as long as you have a data in your system, in your backup, there is no problem. Okay, databases are very secure. But when you have this data in a public space, okay, where you want to share this data with another person, okay, that is when the problem arises. One thing you can do is you can create an user account for the other person whom you want to share this information, okay, and give access to him. So when you share this database access to another person, which means that he has access to change the data, edit the data, modify the data. Okay, because he may also need to do something. Okay, so there is a problem in it. For example, if two people are working on one single source of data, there are chances that you will get into a problem where the data which I added, someone else modified it, right? So I've created a data, put some entry saying that okay, XYZ on January 1st, 2020, and the other guy comes in and he edits the data and modifies it to ABC January 2020. So now the problem is, after 6 months, you suddenly go back and see there is ABC instead of XYZ, and you don't know when it was changed. You don't know whether the other guy changed it or you yourself changed it. Okay, it goes into complete mess. Okay, it's a very small example, but the kind of data manipulation that goes on, you will never have a control of what is happening with the data. So this is a big problem. Okay, you want to safeguard your data. At least when you are sharing it with, you have to make sure your data is not compromised, right? So that's one problem. So what we used to do, in the sense, the industry, okay, the IT industry, what they came up with a cool idea called distributed systems. Okay, distributed systems are very simple concept. Basically, you will share this information in multiple places. Okay, you will create another copy of this data and give it to the other person. Okay, so I have my copy and you have your copy. Cool, my data is safe with me and your data is safe with you. We both have the same copy, so it's the same data we access, but it is physically in a two different places. Okay, it's a replica. You have another copy, entirely copy, right? It's like a Xerox copy. But the problem is that this Xerox copy, or this distributed data, the data which lives in my computer as well as the other person's computer, the problem is that, let's say I have a very important update to my system, okay, saying that let's say a record that was created to on last year, it is no longer valid, so I want to delete it. Okay, so you are deleting that particular record in your copy, but the problem is that that change will not get reflected in the other person's database. So other person database is still referring to the old data, which is no more relevant. Okay, for example, let's put it simple. I'll give you an example. For example, your database has the information about price of the real estate. Okay, so you have a list of cities. Let's say you have like 1,000 properties in a city, and each property has certain value in it, and you have entered this data, and you want to share it with one of your business partners who takes care of another city, say for example, or same city in another area. Okay, so he shared this data with him, and he has one copy. So over a period of time, what happens? The entire value of these properties gets changed next year. Let's say it was 2 years old data. So today the prices are not relevant anymore. So you are now changing all the value, which is the price value of all the properties, but this information is not getting reflected into the other system. Okay, so in order to build really working distributed data, it is important this data changes wherever the system is made it gets reflected in the another system, right? So this database, two different nodes, for an example I've given two, otherwise it could be 10, 20, 30, there is no limit for this. Okay, but this data has to be kept in sync. Okay, so when somebody changes in the right hand side of the system, that has to get reflected in the left hand side of the system. Okay, so A computer makes the changes, the B should also receive that change, and the B computer makes some changes, the A also should receive it. But again, it goes back to the same old problem, right? So if somebody changes, you also change, that gets changed the other place, and he changes something, that gets changed here. So again it mixes, right? So you don't know, oh my god, so now we are back to square one. So keeping in sync is not sufficient. We have to do something more to make sure to understand what is actually the truth. Okay, because I'll give you the same example. For example, you and your business partner share the list of properties in the city and its value. Okay, for example, your business partner by mistake he changes the value of the property to 2x. Okay, say for example a building costs 3 crores, he changes it to 6 crores accidentally by mistake. Okay, and what happens, your both database gets synced, and that property becomes 6 crore in your data, which is a mess, right? You will not know that it is changed, or you will never know when it is changed. Say for example you are looking this data after another 6 months. Okay, it's impossible for you to even realize that there is a data change happened, right? That's a big problem. So how do we solve this problem? This is a problem, right? So solve the problem of sharing the data, but we did not solve the problem of your data getting compromised, right? So that is still there. Okay, so one way, or possibly the best way that blockchain has come up, is by making this data immutable. What do you mean by immutable? Which means you will create a data structure in a way that any data that is existing, you should not modify it. Okay, you can add one more data saying, okay, this is the new data. Okay, for example, if there is a property, let's say property called Big Ben. Okay, that's the timepiece in London. Okay, so you put a price, so there is an initial price for it. Okay, or let's say Taj Mahal in Indian context. Let's put a price for it. Let's say the Taj Mahal costs 50 crores today. I mean, hypothetically it could be more. It costs let's say 50 crore, and that was the initial record. So for that was, let's say that was a 10-year-old data. Okay, it was 50 crore 10 years back. Today it could be 500 crores. Okay, so what happens is, instead of changing the value of 50 to 500, you will actually create another record saying Taj Mahal date so and so date, the price is 500 crores. So what happens now is, you have one data that says 50 crores and you have another data which says 500 crores, but these both data is time stamped, so you will know by the latest value of this property is 500 crores. At the same time, you will also know the original value of this property was 50 crores. and that was 10 years ago. So you will have an audit trail of this information. So by making this data structure in a way that you can only append data and not modify data, you achieve data what do you call security, I can say. Yeah. So you have achieved, you solve the problem of your data being compromised. So what happens in a distributed network? You create two copies of the data, and both are immutable data, and both are distributed, which means every time someone adds the data, a new data is added in the other system also. It is actually in sync. Okay. In blockchain world, we call this a consensus algorithm. So a consensus algorithm's job is to make sure everybody has the correct copy. Okay, you and I should not mess with each other's data. Okay, both should have an agreed copy. That is what a consensus is all about. So that's exactly what we call it as blockchain. Right? So that's blockchain for you. In a nutshell, I will say blockchain is a distributed append-only database driven by consensus. Sounds fancy, isn't it? Yeah. So that's that fancy. What we will see next is we will talk through a little bit of history. But before we talk through this history, I think I'm showing you certain slides and explaining you something, but it will be always good to see, happening. So what I'm going to do now is I'm going to show you a demo of how a blockchain actually works. Right? Isn't it cool? Yes, it is. Let's see a demo and then we'll come back to this. Yeah. Great. Now we say blockchain. It's okay, we understand it is distributed, it is immutable, it is consensus driven. We understand that all, but like still couldn't get your head around it. Don't worry, I have a demo application which actually demonstrates how blockchain works in the background. Okay, so I'm going to show you that. Before I show you that, it is important that you understand the concepts of hashing. Okay, so what is a hashing? Okay, to put in a definition, hashing is a unique fingerprint of a data. Okay, when I say fingerprint, I literally mean a fingerprint. Okay, so I have gone into this website called onlinemd5.com, or you can go to any online. So go to the Google and say online hash. Okay, so it's going to give you many websites. You can go into any website. I have chosen the first one, which is onlinemd5, and when you go into that, you will have an option to choose different types of algorithm: MD5, SHA-1, SHA-256, and all that. So don't worry, you can select any of this, doesn't matter. Okay, so you will, we will explain that what is SHA later some point of time. Now it's not important. Okay, just remember, hash is a fingerprint of a data. So what is a fingerprint? For us, a fingerprint is an unique identification, right? So my fingerprint always is mine. Okay, nobody else can have my thumbprint, right? That's why we all have this fingerprint technology in our mobile phone nowadays. In olden days, those who did not had education, instead of their signature, they used fingerprint as a signature. Okay, so a hash is the same thing for a data. Okay, let me tell you how. For example, let's say there is a word called hello. Hello. So when I typed hello, you see that some strange string got generated here. Like, it's really long string, right? And when I type that, okay, you see that WORLD, that keeps changing. Did you notice that? Let me type again. Hello world. This is Shankar. Welcome to my Hyperledger Fabric tutorial. Cool. Hyperledger. Okay, so there are spelling mistakes, don't mind, but I think you got the picture. Okay, so you add data, the data keeps changing. Okay, so for this hash to get generated, even a dot is sufficient. Okay, the hash of hello, and the hash of hello dot you can see that it's entirely different, right? Check. Hello, hello dot, hello, hello dot, right? So I think by this time you would have noticed certain things. Okay, one, the size of this random string remains the same regardless of your input. Okay, so whatever the data I have, okay, so it's a such a huge data I'm typing. Okay, something. So whatever size, okay, so for such a long string you have the same size. Okay, and let's say I put a smallest string, let's say hi. Okay, I just typed a, let's say a. Okay, the smallest string also has the same size. So hash, the length of a hash is always same, remember it. Number two, it always returns the same value for a given data. Okay, which means, let's say hello. Okay, so you can see that 2CF24. Okay, forget all these things, you can't remember it, so just remember this 4 or just 3. Okay, 2CF. Okay, what I'm going to do now is I'm going to change the data. Okay, completely changed. Okay, but let's say I'm trying to generate the hello again. You see that 2CF2, it's same, it's again the same. So hello, no matter what, will always give you this. Okay, so hello will always generate this 2CF in SHA-256. Okay, so that is what you need to remember. Okay, and you make a smallest change in the string and your hash completely changes, totally something else. All right, so you can put any data. You can be a string, it can be you can generate the hash for an entire file. Okay, you may have some 10 GB software. Okay, you can generate a hash for it. So hash is like a if you know this concept called checksum, so basically this hash is nothing but a checksum of your data. Okay, you compare this hash with the data and you will know, yeah, this is the data, right? So I hope you understand hash. What we're going to do now is going to see this blockchain demo. Okay, I'm going to refresh it once. Okay, what we're going to show now or see now is a small demo of blockchain. Okay, we'll try to understand how a blockchain works. Okay, it's a very interesting demo. It's an online demo. It is actually a visualized view of blockchain. This is not the actual blockchain, but it just gives you an idea how blockchain stores information in the background. Okay, so what you see now is just a visual representation. Okay, it's like something. So what happened now is, like, I go into this website called blockchaindemo.io. There are like few other websites also, but I found this very nice to see. Okay, so let's go back to our session, what we discussed. So number one, you want to share this data with somebody, right? So start with, always every blockchain has something called a genesis block, which means first block. Okay, the starting block. Okay, so I want to share this information to one of my friend. Like, let's say here in this example, my name is Satoshi, and I want to share it with another friend. So I'm going to add a peer. A peer is another partner, another copy of this data. Okay, so there is another peer, and his name is Brett. So what I'm going to do is I'm going to sync up my data. Okay, let's see what Brett has. Brett also has a genesis block. Satoshi also has a genesis block, right? So both genesis block is good, but these two guys are not connected to each other. So I'll sync them up. It says I got a message connected to peer Brett. Okay, so doesn't matter, now these two guys are synced up. Okay, are they really synced up? Let's figure it out. Okay, so I'm now Satoshi adding a data. Okay, hi, my name is Satoshi, and I say add new block. Cool. So it has created my first block. It says block 1, and there is a genesis block, and you see the data, there is hi, my name is Satoshi. Okay, let's see what data is there in Brett's system. Wow, he also has the same block. Hi, my name is Satoshi. I think there is a mistake. Instead of his, I just typed I think there is not a problem. Okay, now let Brett add his data. I think he just added with an empty string. Okay, so go back to Satoshi and see, yeah, he has an empty string. Okay, there's no data, but he still created a block. Okay, so what happened now? Brett by mistake created an empty block. So he creates a new block again, saying, hey, that was a empty block. I am Brett. Empty block. Cool. So Brett has added another block, and let's see what Satoshi sees. Satoshi also has the same set of blocks. See, there is an empty block, there is a block that says I'm Brett. Okay, so let's try to understand each block, how it looks like, what is what. Okay. So Genesis block has 3 information, or actually let's say 4 information, and there is one more information also. Let's not worry about this, it's called nonce, but as of now forget it. Okay, now remember, this block has something called a data. This is the actual information, and this has something called a previous hash. This is the connecting stuff. Okay, and it also has a hash. Since this is a Genesis block and there is no blocks created before this, the previous hash will always be empty. Okay, there is no information added. Okay, and it has something called a date and the name of the block. Okay, or a number of the block. Okay, so let's see what happened when we created our first block. Okay, so we added a name or a data, and it referred the previous block, which is this. Okay, Genesis blocks hash. Okay, and it created the timestamp, created a name called block1, and putting all this together, it created another hash. Okay, this hash is the signature of this block. Okay, so when you create a new block next time, this is going to be in its previous hash link. Okay, 00C. Let's see if it is there. Okay, 00C. Yeah, you can see that, right? So this hash will become the previous hash of the next block. Similarly, this hash, this is 00D, becomes the previous hash of next block. Yeah, 00D, you can see that here, right? So now both of them has same copy. Whenever anybody adds the data, it gets synced with each other. And what happens if someone tries to change the information? Say this Satoshi comes there and, like, I'm trying to secretly sneak in, try to change them data, and he just changes the data in the block. Bang. What happened? You see that every other blocks become red. You saw that? Boom. Okay, this guy did not get that information because this chain is broken. Why this chain is broken? Because here in this block I tried to change the hash, so this hash changed. Okay, this is 27E, this is, so this previous hash again changed and everything else changed, and the last hash, right, 0138 is not same here. So the final hash will always be different. So what blockchain does is it actually compares the last hash, okay, finally generated hash. If it is not same, then it will simply not agree. Okay, it will say, hey boss, hold on, stop, you made something changes in between that is not agreed, I'm not going to take this. So this will be an invalid chain and never be accepted in the blockchain data. Okay, you can see that. So I go back, make it same. Now you see that everything is green, all back to normal. The last one is 006 and the last one is 006, right? So you change one information, okay, anywhere in this chain, okay, from that point onwards your chain will become invalid. Okay, the only way you can add a data is adding a new block. Okay, let's put it here. Hi, my name is Satoshi. Earlier missed I made a mistake, something. Okay, so this is a valid new block because it's a new block. Okay, so it gets added here also for the Brett. Yep, cool. So this is a very cool demo. I recommend you go and try it yourself. There is something called this secret sauce called nonce. Try to figure out by your own what is this number is all about. But I think this gives you an essence of how blockchain works. So basically in real world, this is how your data is getting stored, and it keeps on increasing like 10,000, 20,000. There is no limit for this data, and there is no limit for this size. But size, there is a limit. Okay, every blockchain sets some size for this block. For example, this block, if I set as 10 MB, you cannot store more than 10 MB. You have to split that data into something else if you want to create, add such a huge data. So a minimum or a maximum size is set for each block usually. But in a private data network, you can set that to very big. Like you can say each block maximum it can accommodate 1 GB or so. It's up to you. It's a configurable stuff. But in a public blockchain, the block size are always limited. Yeah. I hope it was useful. So let's now go back to our history. Yeah. So let's figure out how this blockchain history came up into the industry and what is the current state of the blockchain. Yeah, let's discuss that now. So welcome back to the history of blockchain. So now we are going to talk about the evolution of history. So we understood what is blockchain, how it works. So we understood the basics of blockchain, and now we are going to discuss about how blockchain has evolved over the period of time. Okay, when I talk about history, I have to obviously start it from Bitcoin. Okay, there is the blockchain as a technology came into existence because of Bitcoin. Bitcoin has paid a way to do that. Okay, so it was year 2008. Bitcoin was introduced to the world as a paper. Then the next year a working software was published, and then from then Bitcoin, the rest is history. All know what happened to Bitcoin and what is the current state, right? So Bitcoin is the mother of all cryptocurrencies. Okay, well, we'll not talk in detail about Bitcoin, but one thing you should know, Bitcoin is an application. Okay, it can do only one thing, which is playing with the currency called Bitcoin. Okay, so it has Bitcoin. You can buy Bitcoin, sell Bitcoin. That's all. You can mine Bitcoin. Okay, that's the third thing you can do if you have GPU farms. Okay, it's like you can't do that in your PC or laptop. So that's the Bitcoin. Bitcoin is basically a cryptocurrency, and it is used only for cryptocurrency. The entire network is only for the use of buying and selling Bitcoin. Okay, that is all Bitcoin is all about. Okay, but that was not sufficient for there are a lot of industries. The potential of blockchain was more. Okay, so that is what this guy Vitalik Buterin. Okay, he was actually one of the contributor to the Bitcoin code. I think so. So Vitalik Buterin, what he thought, okay, Bitcoin is good, okay, but it is not sufficient enough. Okay, so for a banking application you cannot use Bitcoin. Okay, for an insurance company they can't use Bitcoin. I mean, they can use as only a currency, but other transactions, there are so many transactions that they do. Okay, so is that any way we can use blockchain? Okay, that is what Vitalik Buterin thought, and he created this beautiful blockchain framework called Ethereum. What he did was he simply created a small plugin, okay, and he called it as a smart contract. Okay, it's just an empty space in blockchain. Okay, so in that space you can put a piece of code. Okay, this piece of code is nothing but your business logic. Okay, a business contract. Okay, you will say, for example, let's say you are running a business and you wanted all your partners to vote for certain things. Okay, for a policy change among yourself. Okay, you are dealing with some transaction where a transaction fee is 20%. Okay, and you all think that 20% is not correct. We'll make change into 10%. So for that everyone has to vote. Okay, so you can build a voting application on the smart contract so that everyone will vote for the percentage they are agreeing with. So once everybody agrees it, from now on, okay, so the transaction fee will not be 20%, instead it will be 10%. Okay, so it's just an example I'm telling you. So like that you can build any kind of contracts that parties has to agree to. Okay, instead of just transferring one number to another number, you can do a lot more than that. You can actually put in your business logic into it. Okay, that is what Ethereum smart contract is all about. Okay, he created something called smart contract. Okay, so to give you an example what smart contract can do, basically it can do many things. You can write simple checks and balances in your network. For example, let's say you build a blockchain network for paying your telephone bill. Okay, so what happens, so this smart contract, you can write logic to check whether you have a balance in your bank account to pay a bill. Second, it can check whether you are actually a subscriber. Okay, first of all, to actually pay a bill. Okay, and when you're paying a bill, you can put a check whether you have an existing dues, right? So these are some basic examples of what a smart contract can be. A smart contract is a little bit different from an actual contract. A smart contract has parameters, it has certain values, it has certain checks. Okay, not a textual clauses. No, it is not that. It's basically a self-executing piece of code. Okay, that is what a smart contract is all about. Okay, so let's so we understood what is a smart contract. So which means a smart contract is converting a Bitcoin like application into a an application that will work for healthcare, an application that can work for insurance, an application that can work for your personal need. Okay, so that is what a smart contract is all about. Well, that sounds very good, very nice, but then the problem the world sees or the industries looked upon is, okay, it sounds good, you have a smart contract which everyone has to agree, it is going to be on a blockchain, nobody can change the contract. Okay, because it's blockchain, right? Nobody can delete the data or modify the data, so the contract cannot be changed. It holds good as long as it is there in the network. But the problem is, for an industry, they don't want their data to be in a public forum. Okay, even if you encrypt and put it, it is still a public data. Okay, it's available for everybody to give a try to decrypt it back. Okay, so you put it as it is, or you put it encrypted or decrypted, whatever the way, they don't want to expose their data to the world. Okay, a company does not want to put in their price, okay, original price, okay, in which they are paying it to different dealers. Okay, a financial company don't want to put their data in a public blockchain like Ethereum or Bitcoin. It doesn't make sense for them. Okay, so they wanted this technology to be running in a closed rooms. Okay, which means, let's say I am a bank and I have a consortium of like 10-12 banks, and whatever transaction that is happening between these banks has to be on a network, but at the same time it should not be on a public forum. So they wanted a private setup of the blockchain. So that was a need. Okay, that need led to something called a private permissioned blockchain. So some of the very popular frameworks are Hyperledger Fabric, R3 Coda, there is Ethereum Quorum, it is an Ethereum version of private blockchain, and you have multi-chain. There are a few more also, but I think these are the very popular ones. Among these, R3 Coda and Hyperledger Fabric are very popular. Most of the financial institutes, they chose R3 Coda, and all other institutes like manufacturing, supply chain, healthcare, these industries, they chose Hyperledger Fabric. So there are some reasons why they chose R3 or why they chose Hyperledger Fabric. Because R3 was built keeping the financial transaction in mind. Okay, whereas Hyperledger was built keeping the supply chain in mind. Okay, so whichever the business suits the features of the blockchain, they adopt that particular framework. So, but we are going to discuss only about Hyperledger Fabric. So, well, let's just focus on that. Okay, so so that's the introduction about Hyperledger Fabric. I think I've told you the examples and everything. So what are we going to do next? Okay, next I think it is time to jump into the actual interesting part, coding. Yeah, okay. So a little bit background about Hyperledger Fabric. It was actually developed by IBM, and later they figured out, okay, this is a very cool technology. I don't want this to be proprietary and in a closed room. I want to make this popular. So they think the input should come from all around the world. So they gave it to the Linux foundations as an open source, and the Hyperledger is an umbrella of many projects. Fabric is one of the project under Hyperledger. Apart from Fabric, there are many other blockchain projects that Hyperledger is doing. For example, Sawtooth, Burrow. I couldn't remember others right now. Okay, there are few others also. Not only the blockchain projects, they also have tools that supports these projects. Okay, like a blockchain explorer, Quill, Composer, and stuff like that. Okay. So that is Hyperledger for you. So that is all I wanted to tell you in terms of an introduction. So it's just to set a base, okay, to start. So thank you for listening to the video. I have look for the next video where we'll actually start from downloading, installing, writing a chain code, building an application on top of it, and we'll do all those things in upcoming videos. So please support me. Thank you.